very good morning, students. Today in oceanography, we'll be dealing about coral reefs and atolls. Coral reef, ridge or hummock formed in shallow ocean areas by algae and the calcareous skeletons of certain coelacantharians, of which coral polyps are most important. A coral reef may grow into a permanent coral island, often called the rainforests of the sea. Coral reefs are home to spectacular variety of the organisms. After this lesson, you will be able to understand the corals, their formation, coral reefs, their types, theories of their formation, threats to the coral reefs. A coral reef is actually a complex of features, only part of which is a living coral or algal framework, although the other associated features result from this live segment. The accumulations of carbonate, sand and mud provide a habitat for sea grasses and mangroves and for almost inconspicuous blue-green algal mats. These plants and algae trap and stabilize sediment, and their accumulations are also accreted to the whole reef complex. Storms and surf heap up the fragmental material into beaches and shoals, and the shoals may develop into low sandy or ruby islets or cays on the tops of the reef. Coral polyps resemble sea anemones, to which they are closely related, but unlike most anemones, most reef corals are colonial. Initial polyps divide themselves into daughter polyps, and they divide in turn, growing into colonies that can be up to several meters in diameter, all held together in one continuous rigid calcareous skeleton. They remain attached to the sea floor and become so large and heavy that only storms disturb them. Under the right conditions, generally clear and well circulating water that is not too rough, the corals grow profusely side by side, even on and over each other. The corals in effect build limestone because their skeletons are made of calcium carbonate. Reef building corals, chiefly the stony corals or Scleratenia, grow best in the shallow sunlit water between the low water mark and depth of 11 meters, but they can still construct reefs in water as deep as 40 meters, and they may have a sparse existence between 40 and 55 meters. These corals prefer water of normal salinity with an annual maximum temperature of 22 degrees Celsius but below 28 degrees Celsius. The reef building activities, however, may be carried on in waters whose minimum temperature in the winter is not less than 15 degrees Celsius. A second group of corals in the present day seas grow in thickest and copicus that develop banks rather than reefs on the outer, deeper, colder and darker parts of the continental shelves and platforms. These organisms flourish in water with a winter minimum temperature ranging between 4 to 15 degrees Celsius at depths of about 60 to 200 meters. In any one thicket, there are commonly only two genera of delicately branching corals involved. Such coral banks are known along the eastern Atlantic shelf edge or the continental slope from Norway to the 𝗕𝗏𝗺𝗏 Islands, and again off the Niger River Delta and in the West Atlantic around the Gulf of Mexico. The Bahamas and the Orinoco River Delta of New Zealand, such banks have been recognized on the Campbell Plateau and the Chatham Rise. They also occur in the Northwest Pacific near Japan. The third coral assemblage of the modern seas is associated with even colder or deeper seas. It consists of small solitary corals of relatively few genera known from the abyssal floors of the oceans and from the shelves around Antarctica, Patagonia and the Falkland Islands in the waters 2 to 6 degrees Celsius in temperature. Conditions for the growth of the coral reefs. The coral and the associated organisms and algae, which are the most common reef builders, are confined to the tropical belt. the water temperature must not fall below 20 degrees Celsius and not exceed 35 degrees Celsius. The most favorable is 23 degrees Celsius to 25 degrees Celsius. Corals can live only in saline water, and for their proper growth, the average salinity should be between 27 to 40%. For the growth of the corals, the depth of the water should not exceed 200 meters. Most vigorous growth is confined to the shallow water less than 50 meters deep. Corals also require sediment-free, clean water which is disturbed by ocean waves and currents and is beneficial for the corals. In the open seas, it is necessary to have platforms which may act as foundations for these corals. These platforms should not be deeper than 90 meters. Types of the coral reefs. The following points highlight the three main types of the coral reefs, the types being fringing reef, barrier reef and the atolls. The type 1, fringing reef. Coral reefs developed along the continental margins or along the islands are called the fringing reefs. The seaward slope is steep and vertical while the landward slope is gentle. The upper surface is uneven and corrugated. Though fringing reefs are usually attached to the coastal land, but sometimes there is gap between them and the land, and thus lagoon is formed between the fringing reef and the land. Such lagoon is called the boat channel. Coral reefs are generally long but narrow in width. The continuity of the coral reefs is broken wherever rivers drain into the seas and the oceans. Coral reefs are basically of two types. For example, the coral reefs facing the open ocean and the coral reefs protected by a barrier. Such fringing reefs are found along Sakau Island, southern Florida, Mehetia Island of the Society group of the islands, etc. Now the type 2, the barrier reef. The largest coral reefs off the coastal platforms but parallel to them are called the barrier reefs. Barrier reefs are the largest, most extensive, highest and widest reefs of all the types of the coral reefs. The average slope is about 45 degrees, but some barrier reefs are characterized by 15 degree to 25 degree slope. There is extensive but shallow lagoon between the coastal land and the barrier reef. Barrier reefs are seldom found as continuous chains. Rather, they are broken at many places, and thus the lagoons have contact with the open seas and the oceans through tidal inlets. Sometimes tidal inlets are so wide that ships enter the lagoons through them. Sometimes the base of the barrier reefs exceeds the required depth for the development of the coral polyps, that is 300 feet or 91 meters. Thus, the existence of the barrier reefs at such greater depth beyond the permissible depth of 60 to 77 meters poses the problem of their formation. It may be argued that barrier reefs might have been formed at suitable depth, but at much later date they might have been subsidence. Great Barrier Reef, located parallel to the eastern coast of Australia, is the largest of all the barrier reefs in the world. This reef is located between 9 degrees south to 22 degrees south latitudes and stretches for a length of 1200 miles, which is 1920 kilometers, and thus covers about 2/3 the coastal length of Queensland province of Australia. The northern and the southern parts of this reef are 128 kilometers and 11 kilometers away from the coast. The reef from the coastal ranges between 20 to 30 miles or 32 to 48 kilometers. The third type, the coral atolls. A ring of narrow growing corals of horseshoe shape and crowned with a palm tree is called the coral atoll. It is generally found around an island or an elliptical form on a submarine platform. There is a lagoon in the middle of the coral ring. The depth of the lagoon ranges between 40 to 70 fathoms. Atolls are divided into three types. The true atoll, which is characterized by circular reef enclosing a shallow lagoon but without island. Island atoll having an island in the central part of the lagoon enclosed by circular reef, and coral island or atoll island does not have an island in the beginning, but later on island is formed due to erosion and deposition by the marine waves. Atolls are found in the Antilles Sea, Red Sea, China Sea, Australian Sea, Indonesian Sea. Funafuti atoll of 𝗧𝗦𝗔𝗧 island is a famous atoll. The enclosed lagoon is 12.8 kilometers wide and 19.2 kilometers long. Theories of the formation of the coral reefs. The following points highlight the four main theories of the coral reefs and atolls. The theories are subsidence theory of the Darwin, standstill theory of the Murray, glacial control theory of Daly, concept of W.M. Davis. Subsidence theory of Darwin. Charles Darwin postulated his subsidence theory first in 1837 and modified it in the year 1842 during his voyage on the Beagle. After close observation of different types of reefs in the oceans, Darwin was convinced that coral polyps could grow only in shallow oceanic waters, though coral reefs were found at greater depths where coral polyps could not survive at any cost. Darwin postulated his theory in order to solve the riddle of this contradiction, that is, confinement of the coral polyps to shallow depth, but their occurrence in practice at greater depth. According to him, the land of the island involved in the origin and the growth of the coral reefs is seldom stationary, rather it undergoes gradual subsidence. According to him, fringing reefs, barrier reefs and atolls are successive stages of the development of the coral reefs. There is further subsidence of the land and the island is completely submerged in the water and a ring of coral reef in the form of atoll is formed. It may be pointed out that Darwin did not invoke sudden and rapid subsidence of the land, rather gradual and slower rate of the land subsidence than the rate of upward growth of the corals, so that they could never find themselves in the deeper waters. It may be noted that the depth of the lagoon does not increase in spite of the gradual subsidence of the land, because there is continuous sedimentation in the lagoon, the validity of the Darwin subsidence theory. The shallowness of the lagoons indicates gradual subsidence of the land. If the land is taken to be stable, the lagoons would be filled due to the deposition of the sediments. The absence of the cliffs along the coral islands validates the idea of subsidence of the land, because cliffs are found along only those coral islands which are stationary. The coasts and the islands of the Pacific Ocean having raised beaches indicative of the emergence of the land are devoid of barrier and atoll reefs. The islands having atolls are characterized by very steep slopes. It may be mentioned that very steep slopes are found only along the upper parts of the islands. This fact also denotes the subsidence of the land. The thickness of the coral reefs increases downwards. This feature reveals the fact that coral reefs are formed along the subsiding base of the submarine platforms. The evaluation of the theory tells us that if fringing reefs, barrier reefs and atoll reefs, as maintained by Darwin, are only three stages of the evolutionary growth of a reef, then fringing reef, barrier reef should not be found on either side of the same island at the same level, but observations and new discoveries have revealed the existence of such situations. Standstill theory of Murray. Theories based on the concept of non-subsidence or standstill situation of the land fall into two categories. According to first group, corals grow upon suitable, stable submarine platforms with unchanging sea level, while according to the second group, necessary suitable submarine platforms became available due to lowering of the sea level and consequent erosion of land by sea waves, but the land always remains stable. The theory of Murray belongs to the first group. Murray propounded his theory of the formation of the coral reefs in the year 1880 on the basis of the information received during the Challenger expedition, which is from 1872 to 76. According to him, coral polyps can live up to a depth of 30 fathoms. Sea level and submarine platforms are stable. Several submarine platforms, volcanic peaks, islands are present below the sea level. If the submarine land platforms are above the permissible depth for the survival of the coral polyps, they are subjected to wave erosion so that their heights are lowered down. On the other hand, if the submarine platforms are below the required depth of sea of 180 feet, their height is increased due to the deposition of the marine sediments. After getting suitable foundation at required depth of 180 feet, coral polyps begin to grow upward along the coast and the fringing reef is formed. The coral polyps after some time also grow outward on the foundation of their own debris. Thus, the continuously outward growing fringing reef is transformed into barrier reef in due course of time. The lagoon is formed between the land and the barrier reef because of dissolution of the dead corals. Atolls are formed due to outward growth of the corals in all directions at the top of the submarine platforms. Thus, a ring of coral reef is formed around the southern solution lagoon. According to Murray, the lagoonward side of the atoll is characterized by dead corals, while the seaward side has living corals which continuously grow outward. The dead corals are gradually dissolved and thus the lagoon is continuously widened. The lagoons also become shallower because of the deposition of dissolved dead corals. Evaluation of the theory. The non-subsidence theory of the Murray claimed wide popularity in the beginning, but later on it was severely criticized on the following grounds. Murray's theory requires the existence of numerous suitable submarine platforms at the depth of 180 feet, but the existence of such features is not possible. Murray has described two contradictory views of the marine erosion and deposition at the depth of 30 fathoms or 180 feet at the same time over different submarine peaks. Such proposition is also not possible. A limit of 30 fathoms for the deposition and the erosion cannot be accepted. According to Murray, the lagoon is formed due to solution of dead corals. This mechanism is also doubtful because if the lagoon may be formed due to solution of the corals, the pelagic deposits laid down on the submarine platforms or peaks would also be dissolved. Glacial control theory of 𝗬𝗓𝗓. 𝗬𝗓𝗓 propounded his theory of coral formation in the year 1915 after he was convinced that coral reefs were formed after Pleistocene ice age. According to him, sea level fell by 33 to 38 fathoms due to glaciation, that is the confinement of the sea water in the form of ice on the continents during the Pleistocene ice age. The existing coral reefs died due to lowering of the temperature of the marine water. Wave-cut platforms were formed along the continental coasts and islands due to abrasion by the sea waves. After the end of the ice age, the sea level again rose by 33 to 38 fathoms due to the return of the sea water, which was imprisoned on the continents in the form of ice during the ice age. In other words, the ice melted due to the rise of the temperature, and the melt water after reaching the oceans rise their levels to previous stage. Thus, the wave-cut platforms were submerged under the sea water up to the depth of 33 to 38 fathoms. The corals, which could survive during the glacial period, and new coral polyps began to grow and establish their colonies on the seaward edges of the submarine platforms. Thus, fringing reefs were formed on narrow wave-cut platforms, while barrier reefs were formed on the broad wave-eroded platforms. Evaluation of the theory. The glacial control theory of 𝗬𝗓𝗓 is criticized on the following grounds. According to this theory, the depth of all the lagoons of the atolls and barrier reefs should be uniform, but actual observations do not validate this concept. According to W.M. Davis, the depth of different lagoons varies considerably. Not only this, even depth at different parts of the same lagoons ranges between 120 to 300 feet in some lagoons, and depth varies between 20 feet to 600 feet. The coast might have been cliffed due to wave erosion during the phases of lowering of the sea level during the Pleistocene ice age. Thus, the cliffs formed during the glacial period should also be present now, but they are seldom found. In fact, the corals might have protected the coast from being cliffed. Concept of William Morris Davis. The famous American geomorphologist W.M. Davis postulated his concept of the origin of the coral reefs in 1914 to 1918 and revived the subsidence theory as postulated by Darwin and others. He presented several physiographic evidences in support of the subsidence theory and to explain hitherto unsolved several problems related to the formation of the coral reefs. According to him, corals grow along the subsiding land. The presence of indented and embayed coastlines found in the coral seas validates the subsidence and consequent submergence of land. According to him, the flatness of the bottoms of the lagoons and their uniform depth are not due to the uniform lowering of the sea level, and these are not true bottoms, but they are due to the deposition of the marine sediments. The shallowness of the lagoons is because of the deposition of the debris. If the submarine platforms are taken to be stable, then the deposition of the marine sediments would fill up the lagoons and the overflowing of water would kill the living corals on the seaward side of the reefs. The threats to the coral reefs. A number of forces threaten the survival of the coral reef organisms as well as the structural integrity of the reefs themselves. Many coral reefs are plagued by predatory species, bleaching, and the effects of various human activities. Crown of the thorns starfish. Certain biological factors such as the fish and the invertebrates that feed on the soft tissues of the reef builders and the organisms that bore into the coral rock may contribute to the destruction of the coral reefs. One of the most destructive creatures known is a 𝗪𝗏 𝗪𝗏𝗪𝗏, the crown of the thorns starfish, which during the 1960s multiplied spectacularly and removed the soft tissues from large areas of many reefs in the Southwest Pacific. A 𝗪𝗏 feeds by everting its stomach and liquefying the absorbing tissues of the corals. By the late 1970s, it had become apparent. However, the sudden spread of A. 𝗪𝗪𝗪 was part of the organism's natural life cycle and that the coral reefs could regenerate rapidly after such an infestation. Coral rock borers include boring algae, boring sponges of great significance, various polychaete and many bivalves and few gastropods. These organisms usually penetrate the rock mechanically, but in some cases do so chemically. Extensive damage is caused by both their own activities and by assistance they give to the erosive action of the sea. Being the coral bleaching. A phenomenon known as bleaching caused extensive devastation among the coral reefs in the East Pacific since early 1980s and in the Caribbean Sea since the mid to late 1980s. It is called bleaching because zooanthellae are golden brown in color are expelled, leaving the white coral exposed. While the cause of the bleaching is not yet fully known and extensive research is underway, it is believed that most likely factor is unusually high seawater temperature, approximately 30 degrees Celsius. Other factors linked to coral bleaching include rising acidity associated with the increased absorption of the carbon dioxide by the oceans, ultraviolet radiation exposure, drying from extreme low tide events such as those associated with the El Niño, sedimentation, pollution and the disease. Coral reefs begin to form when free-swimming coral larvae attach to submerged rocks or other hard surfaces along the edges of islands or continents. As the corals grow and expand, reefs take on one of the three major characteristic structures: fringing barrier or the atoll. Fringing reefs, which are the most common, project seaward directly from the shore, forming boundaries or borders along the shoreline and surrounding islands. Parts of the reef platform may emerge as one or more islands, and gaps in the reef provide access to the central lagoon. Thank you.